You might think you know how to plant a peanut,
Yeah.
right? But what if nature's got a secret you've been missing all along? Today, we're uncovering a really fascinating observation from some recent notes on gardening. It completely upends our assumptions about peanut germination. And honestly, it might just change how you approach your garden. Get ready to have your expectations, quite literally, re-shelled.
Yeah, it's quite something. We're diving into this captivating discovery, something shared by a very observant gardener. It really challenges our conventional wisdom. It's about how plants, specifically peanuts, actually start their journey from seed to seedling. And it highlights this remarkable aspect of their innate resilience.
Okay, so our mission today, let's lay it out. We want to uncover the specific conditions that allow this incredible natural germination to happen. And, understand what this means for us, whether you're a seasoned gardener, just curious, or maybe you just love a good aha moment about nature. Because this isn't just some cool botanical fact, is it? It feels like it has real, tangible implications for how we interact with the plant kingdom. Okay, let's set the scene. Because this story, it really starts in the most unassuming way. Imagine someone, they're just identified as Ang in these notes on gardening. And Ang was doing something perfectly routine, just clearing out old seed germination projects, a bit of garden tidying.
Yeah, like recycling used seedling soil from a peanut harvest they'd just done.
Exactly, the kind of mundane chore we all do without really thinking twice. You scoop, you dump, you move on. Right?
Right. And it's precisely that everyday quality that makes the discovery so powerful. Aang wasn't, looking for anything extraordinary. They were just being diligent, maybe returning spent soil to the compost heap or getting it ready for reuse. It's a moment most of us would just breeze past.
Totally. But then something subtle catches Aang's eye. And here's where it gets really, really interesting. Amidst the discarded soil, Aang discovered something genuinely fascinating. Peanuts reseeding themselves while still in their shells.
Still in the shell, yeah.
Not just a stray seed, but clear, unmistakable evidence of germination happening inside that protective shell. And like you said, this wasn't some big experiment designed to prove a point. It just happened organically. A quiet little revelation during that simple act of recycling soil. Such a testament to just paying attention, not dismissing things that seem a bit weird.
That's exactly it. What's truly fascinating here is that point, it wasn't some intentional controlled experiment. It was just a natural occurrence, observed during routine work, a hidden process revealing itself. It speaks volumes, really, about nature's inherent persistence, its resilience. And it shows us how much we can learn just by, paying close attention to what's actually happening around us, in our gardens, or even in forgotten corners. It's a powerful reminder that, profound discoveries aren't always found in complex labs. Sometimes they're right there in the simple stuff. It definitely challenges us to look beyond what we expect to see.
That really is astonishing. It makes you feel like nature's been playing a little trick on us this whole time. But you're right, the big question is, how? How did this happen? Because for most of us, planting a peanut always involves that step, right? Cracking the shell, getting the kernel out. So what did Aang's notes actually say about the conditions? What made this possible?
Exactly. And the notes from Aang, they clearly detail the conditions that made this unexpected germination happen. It wasn't about special tools or, elaborate prep work. The K factors were pretty simple. The right amount of moisture, so consistent hydration but not waterlogged.
Okay, moisture. Makes sense.
And surprisingly, the observation was that this could happen even at a depth greater than the seed size. So that combination of factors was enough. It's just a powerful testament to the plant's innate ability to find a way, doesn't it? Even when we think it needs our help.
Right.
The process itself, it's quite simple but also profound. That consistent moisture softens the shell over time.
Yeah.
And then the slight uniform pressure of being buried provides the counterforce needed. Think of it like a tiny natural pressure cooker.
A pressure cooker.
Okay. Yeah, sort of. So the embryo inside, it senses these optimal conditions, it starts to swell up, and it gently pushes against that softened shell. It's not like a violent break, but more a gradual, deliberate splitting, maybe along a natural seam or just a weak point in the shell. And that split then allows the radicle, that's a little embryonic root, to emerge first and anchor the plant. Then the cotyledons, the first leaves, they start developing. And all of this happens while it's still kind of using the shell for protection in those first crucial hours. Ang even mentioned seeing 2 young peanuts in their early stages, which have just begun to develop,
Right.
which means it's a full self-contained germination. It's progressing through its initial stages without anyone needing to remove the shell. The seed just uses its environment to break free and start its life cycle, entirely on its own terms.
So wait, the seed doesn't just germinate inside a shell that happens to be broken. The seed around growth makes the shell crack open.
That's what the observation suggests, yes.
Uh,
The internal pressure from the swelling embryo against the moisture-softened shell.
That's the part that really boggles my mind. It implies this incredible force and timing from such a tiny thing. I'm just picturing all the times I've sat there painstakingly shelling peanuts for like kid science projects or for the garden bed, thinking I was doing it a favor. And all along, the peanut was probably just thinking, mate, I got this.
Mm-hmm.
Could be.
So, okay, for the seasoned gardener listening right now, my first thought is efficiency. If this actually works reliably, are we talking about a complete paradigm shift?
Yeah.
Could we just ditch shelling peanuts for planting altogether?
That's the million-dollar question, isn't it?
Or, hang on, are there maybe specific types of peanuts or certain conditions where this method might not be the best idea? What are the practicalities or potential pitfalls?
Right, and that's a crucial line of questioning because it moves us from just observing something cool to thinking about practical application. If we connect this to the bigger picture, this discovery strongly implies that it's possible to induce peanut germination without even removing the shell. Just think about that for a second. It directly challenges a really common gardening practice.
And it highlights the plant's amazing resilience and self-sufficiency. For large-scale growers, imagine the potential savings. Reducing labor costs, processing time, bypassing manual or mechanical shelling for planting, that could be huge.
Definitely.
And even for the home gardener, it's just a massive time saver, isn't it?
No kidding.
Now, to your excellent point about downsides or limitations, the notes themselves don't cover every possible scenario, but we can infer a few things. Firstly, while that shell offers protection, it could also potentially harbor fungal pathogens, right? If the moisture levels are too high for too long, you could get rot before germination.
Ah, okay, good point.
Secondly, the shell might attract certain pests, maybe things that wouldn't normally go for a bare seed.
Like little critters looking for a whole meal.
Perhaps, yeah. And finally, while we know it's possible, the actual rate of germination for in-shell peanuts versus shelled ones might vary. It could depend on the peanut variety, the soil type, the climate. For instance, dense, heavy clay soil might make it harder for the shell to soften evenly, or for that little root to push through, compared to the lighter, sandier soils peanuts usually like.
So it's a powerful possibility, but maybe not a guaranteed fix for every single situation.
Exactly. Which raises an important question, I think, for you, the listener. How many other natural processes might we be overcomplicating? In our gardening, maybe in other parts of our lives? How much of nature's self-sufficiency do we miss because we just impose our own assumptions? Always thinking our way is the way. This discovery, it sort of offers a shortcut to understanding. It suggests that sometimes maybe less intervention from us is exactly what's needed. Let nature do its thing. It's definitely a reminder to question our practices and just learn from simple observation.
I really appreciate that balanced view. It's not just great, throw whole peanuts in the ground and walk away.
No, not quite.
But it is a clear sign that maybe we're doing more work than necessary sometimes. And this isn't just about peanuts, is it? It makes me wonder about other plants too. Are there other seeds we've been meticulously prepping for planting that, given the right conditions, might be just as self-sufficient? Could this observation fundamentally shift how we research or experiment with seed propagation more broadly?
Absolutely. That principle isn't unique to peanuts. Lots of seeds have natural mechanisms to break dormancy or shed outer layers. Think about the hard casings on some legumes or the stratification that tree seeds need, that cold, damp period.
Right.
What Ang's discovery highlights is that sometimes these mechanisms are far more robust, more self-executing than we typically assume, or maybe even test for in controlled lab settings. It's really a call to observe nature's inherent intelligence more closely. It suggests that our conventional methods, while often effective, might sometimes be overcomplicating a process that nature is perfectly capable of handling on its own if it gets the right triggers. It definitely encourages us to think about how we can work with these natural processes rather than constantly imposing our own sort of human-centric solutions.
What a journey into the hidden life of a peanut. It's truly amazing what you can discover just by being observant. Even with something as familiar as a gardening project, it really underscores that there's so much more going on beneath the surface, or in this case, inside the shell, than we often assume. It just urges us to challenge those deeply ingrained assumptions, doesn't it?
It really does. So, as you go about your day, maybe consider this. What other natural germination discoveries might be hiding in plain sight, waiting for someone just like you to notice them, simply by paying a bit closer attention to the world around you? What insights could you gain, maybe not from complex experiments, but just from that quiet, consistent vigilance? Simply observing the unexpected in the everyday.
That's a great thought to end on. Thank you for joining us on this really fascinating deep dive. We hope it sparked some new thoughts for you, and maybe even inspired you to look a little closer at the world around you, whether that's your garden, your kitchen, or just, a walk in the park. Until next time, keep observing.